let's catch up a bit. So where are you located these days? Where are
Van-
you?
uh, as always, Vancouver, British Columbia.
I thought you
So,
were Seattle for some reason. I'm not sure why.
sorry, where?
Seattle.
Seattle. No, but I was always there at the alt.net meetups after the MVP summit was done. So alt.net used to be always kind of scheduled around the MVP summit at Microsoft, which
Yeah.
was in Redmond.
Are you
So,
MVP, by the way?
oh God, no, they would never, they would never do that.
Oh, God, no. Yeah. So
Gosh,
one day you
man, that's
get an email. Is that how that worked?
well, surprisingly, the company I started, we're officially a Microsoft partner now, so that's kind of cool. We're on our way to becoming a gold partner for all things Azure and all that. So that's the good thing about event modeling is that it's tech agnostic, so
Is
we
it
can
an
apply
engineer?
it whether you're AWS or Azure or whatever. So it's really a nice way to be able to say yes, of course we can support you in Azure, no problem. And of course, since 2008, I've also been a big proponent of open source and not just open source projects like alt.net style, but open source platforms and software freedom, open standards, making sure that we leave a really good world for our next generations to be able to access previous records, get rid of proprietary storage of especially public records and things like that. So I've been quite active in all the Linux and OpenBSD and all these different open source platform and communities as well. So that's been a big part of my life, as well as of course um, accounting like quality in software. I think one of the biggest realizations over the last 10 years is just how software is really, at least line of business software, things that you and I are working with and most people are working with day to day. It's really not that special. I like the idea that there's um, a bunch of any kind of solution, an insurance company or whatever. Each solution as a whole is a unique snowflake with its own interweaving of business requirements and specific things. However, on the molecular level, it's still water, it's still oxygen and hydrogen,
Hold on, hold on.
and those are what's up.
Philosophy. Hold on. The philosophy is like you went deep into open
Yeah,
source.
let's back up. What are you doing? We wrote a book, way more exciting. I'm still writing a book, so
Which book are
let's
you writing?
let's let's hear about what you're doing since 2008, since we last talked
Yeah.
in person.
Are you writing that book since then?
No, this is about a year of effort, just over a year of effort in doing this. Um, it's just an evolving thing, but
What book? What's the name of the
I
book?
recent sorry,
What's the name of the book?
it's event modeling, designing modern information systems. So
The link.
essentially, it's about that there is no link to a pre-order copy yet, but there is a form on my Twitter where you can fill out your name and email, where you can get some initial. I guess there will be a subset of people that do some reviews, but
Cool.
also they'll get the initial links to order it, and you know, at a significant discount or for free, depending on their situation, country, economic situations, etc. I'll be kind to those that need the charity, and I'll ask for a larger price for those that are working at larger companies, so that I can keep this effort going. And
That everywhere.
yeah, I think it's been the main sort of event modeling article has become quite popular. It was top story on Hacker News last year for a couple of days, I think in September. So it's really freed up people.
Okay.
I'm gonna just publish this link that you said on LinkedIn as well.
Yeah, sure. So I want to give you a little bit of background why we're doing this. I've been talking about various ways to design things and test drive things, and I've been hearing about event modeling storming and event sourcing and CQRS and command query separation. And for I think ever since for the past 10 years, and it's been kind of like trickling into my mind in a way, but I've never really gotten into it. I know some of the basic ideas behind it, but as far as I can see, you are so deep into that world that I think you have an understanding that most people do not really possess yet. And whenever I asked weird questions on Twitter, like how would you drive this or something, your answers would always be, oh, it'll be so simple with event sourcing this and event modeling this and event storming this. And it sounds a bit cryptic because you can't really explain things on Twitter. Can you hear me okay?
Yeah, yeah, absolutely. I'm trying to line some things up to just show you a
Okay.
few things here. There is a there will be a sneak peek of a brand new post that's going to be quite important because it actually glues the two worlds you mentioned about how does this event sourced world differ from um, the traditional approaches of ORMs, etc., that people are used to, and the typical approaches. So event modeling is something that in, is all encompassing. It addresses any type of architectures, including traditional ones. And so this was kind of myopic from the community, event sourcing, CQRS, and domain driven design communities. You have to be kind of part of the cult to really get it and be involved. But 95% of the world really is still not really informed on modern types of approaches of ledger based state management or any of these things. So we're really missing the boat for 95% of the population out there. And so event modeling bridges that gap. The latest article, which is not public yet, but will be, kind of covers that. And if you remember the Mythical Man Month, Fred Brooks writes about how systems are put together. And so, should I just do a screen share right now? Because I can
Yeah.
show you the sneak peek to this article. And
Yeah.
if you want, did you want that right now? Can just jump into stuff, like, and just take the
Well,
conversation wherever it goes, right?
let's be agile.
Okay, let's be agile. Let's. I have some interesting things to say about agile too, because there's a difference in how you interpret responsible level of planning and things like that for what you're going to do. But so let's just see if we can show that.
Are you able to share screen?
Yeah, I think so. I'm going to try right now. So can you see that?
Yep.
Okay, so this is the latest thing with. You're familiar with IntelliJ, of course. The JetBrains stuff has been my favorite tooling for almost everything, including even just writing Markdown stuff. So, yeah, one of the things that Fred Brooks said is, "Show me your flowcharts and conceal your tables, and I shall continue to be mystified. Show me your tables, and I won't usually need your flowcharts. They'll be obvious." This is reading between the lines here. This is incredible. This is an incredible level of insight, really early on in the industry of digitization.
Trying to see if
Uh,
I heard this sentence. Is that sentence in the book? I'm trying to remember because I read that book a lot.
I believe so. I think it's one of the chapters. If you look at Fred Brooks' Wikipedia page,
Yeah.
um, that quote I believe is cited there with the page number from the Mythical Man Month, if I'm not mistaken.
Okay, so let me see.
So
Show me flow charts and conceal your tables,
yeah,
and
if
I
you
shall.
take that, yeah, if you take
Right.
that string and Google for it, I'm sure it'll pop up immediately.
Yeah, I'm just trying to literally understand it, like process it in my brain at this point.
Ah,
Right. So show me your flow charts and conceal your tables, and I shall continue to be mystified. Show me your tables, and I won't usually need your flow charts. They'll be obvious. Okay, I kind of like that. That's nice. So if you look at someone's schema at their database, it's gonna well. Technically, I guess you're right because you can see under the covers, you can see exactly how things are under the covers, like the bare metal. But I've seen some schemas in my life, which
yeah, we all have.
right. So I'm sure this only applies sometimes, or maybe that's where event modeling comes in and says, "Oh, it applies if you do X, Y, Z."
Yeah. So one of the interesting things with this statement is you get some a fair amount of insight from being able to see a table of schema. But I think where this can be more beneficially extended, especially if you marry this with the idea of BDD and specification by example, and
Mhm.
show on a timeline how your data is changing, then you'll really understand what's going on. Then the code and your flowcharts are really a means to the end. And the end is to make the information change over time in this way. And it really doesn't matter what algorithms you're using, how your classes are written, what language you're writing, what kind of code format you have. When the power goes off on that machine, that CPU isn't running, what's left is what's on disk. And the disk always, the persistent storage is the master of what has happened. So I extend this. If you looked at the event modeling main article, it's quite famous for being about event sourcing, where you simply start out by specifying your system in these steps, saying what are all the events that can happen. I'm sorry for the small font here. I will try to increase this a little bit for legibility. Unfortunately, the pictures aren't going to be bigger, but uh, right, we kind of brainstorm the events and we put them on a timeline. And very importantly with event modeling is that we include the UX right away. We have what the
Yeah,
people will see on screens. And if
let me.
something is a back-end service,
Sorry, Adam.
we
I gotta stop you for a second
sure.
because let me just try to represent the person who maybe has not heard of the terms event modeling, etc.
Yeah, for
I
sure.
don't think we've even covered what an event actually means.
Right. So an event is really one of the things about event modeling is to use regular English and common sense and not really add any specific terms that you might have, like from ports and adapters or domain driven design, aggregate roots and bounded contexts, and all these different things that people must learn. The aim of event modeling is to really find a very few things to learn and keep in your head and still be able to explain things to people. So, the basic construct for any system is a series of events. I go at the top of this article, I go into the history of why that's important because humans like stories. That's how civilization was built. And we couldn't store stories because in initial computing, because the disks weren't high capacity, yet the processors outpaced them with the advent of integrated circuits and chips. So around the 1950s, we had the transistor, and things became incredibly fast for processing, but there was no equivalent leap for storage of data. So there was a big imbalance. And so that's why we left the idea of a ledger of what happened. And if you think of ledger and events, they're like in the story, the Bible, whatever, fairy tales. We can remember these things, and this is how civilization was built even before we had written word. It was talked about legends and fables that were passed on to our offspring at around the campfire in a cave, if you will. It's how civilization was built, and our brains differ from other species in that we can take this knowledge and give it to subsequent generations. That was the defining gap. So we have some interesting things about our brains, and this is why specification by example and behavior-driven development are highly successful, is because instead of specifying something in some archaic way, we say, here's an example of what happens. And our brains can just take that in and understand it. And so that's why the word event is quite interesting. And the word event is an accounting of what has happened and is an undeniable fact. If we use that as our building block for maintaining state or even explaining a system, as event modeling does, um, then we have something that more naturally works with our brains, and we can get to consensus much quickly and work towards a common goal more quickly, as opposed to some things that were really coming out of the compromise in IT that we had, and we had debacles like UML with 7 different diagrams that concentrated on too much on the how and not the end goals. In other words, getting really lost in the weeds of the details of what the end goal was. And so that's why UML and all these formal practices are ineffective, because to do them effectively, it requires an onerous amount of time to specify everything. You might as well be coding the solution instead of specifying it because of all the details you need to account for. But if we know what to skip we can do it quickly. And a way of skipping all that is saying the most important thing is that with these events, in other words, things that have happened, get stored in the system along this timeline. So if I'm talking about a hotel system automation, I can see what events have happened on a timeline. And if I write a piece of software, if I can then audit that piece of software to see if those events are actually happening in the same way that we described them, then I know I have success. Done is done for the complete system is finished. But further to that, because we have this ledger-like ability, especially since it's immutable, things in history, you don't have a time machine in real life. When something has happened, it's on the ledger and it has happened. So it enforces this immutable ledger as being the way to store things forward. And in recent years, a store forward only Turing machine has been proven that it's still Turing complete. So we can have a Turing machine that doesn't mutate previous entries on the ticker tape and things like that. So it's actually quite nice to work with, even from a computer science kind of viewpoint. But you shouldn't have to explain all of this kind of stuff if you're doing event modeling with your business people. All you can say is that, hey, if we're building something, let's just try and think about all the different events that can happen. In our hotel system, we can say we have had room booked event because someone needs to book a room. Someone has to register, so there's a registered guest. There is a payment made. You can brainstorm all the different events that have happened in your system that you want to build, right? And more importantly, then we can actually put them in order and discuss it with our peers uh, in a collaborative way. And we do this online, especially given today's situation in the world. This is quite important that people can sit like you and I are sitting and go to a Miro board, and I'll show that in a bit, which one of the tools that we use for online collaboration and how these projects actually end up being collaborated on. But we start with the plot, which is really, is this a complete story about using the hotel system? You can make it as involved or as high level as you want, really, or succinct as you want, depending on what is going to be compromising your version one or your MVP. But the very important part is step number 3, because this kind of makes it into a movie storyboard. If anyone's making a movie, they have they have the key frames across a timeline, and underneath they explain the plot. What the characters are talking about and what's making the movie make sense in terms of what maybe was originally implied by the book. That if you're making a movie about a book, but so these are quite important because the top shows what the user sees across as they're using the system across time. At the bottom, it's the analytical part where you see what information enters the system at any time. This is quite important from a number of reasons, because at this is the earliest stage that you can do something that's called information completeness check, which means, do you have everything accounted for in terms of what you're showing on screens? Did you actually receive that information somewhere here before? Or are you making an assumption that it's coming in from their system and you haven't yet shown that that's part of that? And that's where you get scope creep and missing requirements and things like that. So information completeness was a really interesting aspect that I didn't realize how important it was until Chris Condren, a really cool guy that was the former CTO of Event Store, pointed it out as we were presenting these things. Is that information completeness is quite a huge advantage to being able to describe a system. So this storyboard is very valuable at this point, but we can go further to be able to organize our solution so that it makes sense for being able to divide it up upon teams, etc., and for many other aspects. So the next part that we can do is really identify inputs, and that's where we say, like, well, how do these events get in there? And this is where we can glue specific parts of the UI to the event getting on the timeline. So if you have a complex UI, you might have a section, a component in there that's going to give you maybe the registration piece with a couple of fields. Well, you can identify that in your screen and say that this is a register command, and that if it's successful, it has this registered event with the pertinent information stored on our ledger, and then we can go on to the next workflow step. So this is quite nice, and I don't like to use input-output for systems. I like to say that it's being able to effectively change the system that you're working with. So as a customer of a hotel chain, I want to be able to affect that system so my reservation is held and I'm not going to lose it. So this is this is quite nice, a nicer way to say input output. The reason I don't like input and output is that implies in order to get output, you have to poke the system. And that's kind of where you get these false commands where people say that I want to request the sales report. And it's like, well, you're not really changing the state of the system. You're not adding another event. So a request for something is really just viewing the cache of previous outputs based on stimulus before. So I don't like to use input output. I like to say empower the user to change the system. And then vice versa, we identify with green stickies that this is information that we can present. So it's the output. So if I look at a calendar, for example, of available dates for the room type that I want for my vacation, I can see which dates are available. And that is really a live report in essence that just changes as new events are entered. So as new events are entered, the system knows to keep track of those in many different places. One of them is this calendar. And when new bookings are made and the inventory is adjusted, we know that we have to adjust this representation of what dates we have allowed. So that's basically it. Now, further organization means that if we have different subsystems that we want, perhaps we want someone to deal with profiles, maybe something to do with points reward systems, maybe something to do with payment, and maybe something to do with inventory management of the actual rooms themselves, the bookings, etc. We can divide those into swim lanes, and we can see that we now have 4 subsystems that are at play here. Likewise, we can divide up the top to show different actors and how they interact. So the bottom row might be the administrator or the hotel manager and how they check people in when they arrive and other things, set up inventory, take rooms out of rotation. And the top one is the guests coming in, right? Or one particular guest. And you can do this to show how competition between 2 guests for an available room might happen, but it's all by example. And there, usually we want real data in there, right? So this is quite explicit that we have Joe and Mary working through this system and we can see what data comes through, and we're working with real data as per specification by example. And then you get to take advantage of a whole bunch of things. And this is if you do an event sourced system. So one of the things that you'll see is that this is not a traditional table structure. The green things may actually be in tables. These are like your reports and other things. You might have a regular database. But let me juxtapose that with what we do with a traditional system. Because as I said, you can do event modeling for a regular system and do it all online. And you would do that, same thing. You start with a user interface, except registration is just now linked directly to that registration. We don't store this event, but it's important for people to understand that, for example, they put in a secret for their password, right? We can see the password here. However, in the swim lanes, we make further swim lanes to represent records in tables. This is the user table, and we show what gets inserted. We say insert, and we have a hash. So this shows that we can speak with even the CEO of the organization and say, we don't store passwords in plain text. This is your security 101, and you should know that we don't do this. And so even though from the theoretical perspective and from what the user did and had in their brains, their event was actually putting in their name, their email, and their actual password. That is a true event. What our system stored, however, is different, right? So this already implies, by example, what the system's supposed to do. Likewise, we do the same thing for information coming out. So if the next step in our workflow is to show this thank you for registering page and getting a verification code entered, we show that there's a read from the same table. And the further part of this article, which is the next main article in event modeling, is to show a complete system, how you, if you evolve the system in an agile way, how you have to revisit this. For example, let me give you an example of maybe adding a feature for locking out a user after 5 invalid login attempts, right? So that may actually be implemented as perhaps another column in here with a counter for invalid logins, correct? So
Maybe.
if we do that as our 5th or 7th or 10th feature in a backlog somewhere, you notice that we'll have to revisit this functionality to at least make sure that we have entered a correct default value of 0 when someone registers initially. Or we
Mhm.
might have a related table that keeps that. But now we have to ensure that there's a foreign key constraint that is being adhered to, and we have some default data set up. In other words, we've just broken the open close principle, right? Because we were done with this registration piece, but we have to reopen that functionality to be able to later on, for what we get in our backlog 2 weeks, 3 weeks, 1 month from now, reopen this functionality to adjust the state management for this first piece of functionality to be able to take into account the counter for invalid login attempts. And that's
Right.
one major difference between the two approaches of using table-based canonical model approach to systems versus an additive only immutable ledger approach, where we have really Yagni happening here from a perspective, from an agile perspective. Because over here, if we have the same scenario, as we add more features, I'm just adding more events that happen. And some of these things are done only just in time. In other words, once I'm done the registration piece, I don't have to touch that if I'm going to implement a lockout mechanism, as mentioned before. That no longer has to be addressed. So the important part from the event sourcing perspective is that I can adhere to open close principle. When I'm
So
done with this piece of workflow, I'm done. And just to close off before you
yeah.
do that, this really flattens this curve, which is the Achilles heel of all software development. It's the fact that as your system becomes larger and more complex, it becomes more and more painful to add features, no matter if you're being good at test-driven development, etc. The fact is, for new features, you have to reopen old ones. And the more old ones you have, the longer that's going to take. And this is why refactoring a really large test suite gets really tedious, not tedious, but long to take care of. And it's really why, no matter how good the people that you hire are, the initial 2 weeks of a project are greenfield and they're wonderful. It's all sunshine and rainbows, but it's a death march 6 months in because of all the rework that has to be done, right? And so this is one of the things about having an immutable ledger where you can combat the open close principle being violated. And it has a huge impact on test driven development, which is really why I wanted to talk to you, because you're a big advocate of test driven development. And I think this methodology or this understanding of state can really help put a really good scope on just how much you have to refactor. Because TDD, in its current sort of definition, really has no bounds on what is up for grabs when you do refactoring, the refactoring portion. Maybe common sense tells you should probably not go outside of one bounded context or subsystem, right? But for the most part, there's really no guidance. And it's this rework that has to be really addressed, because as the solution grows, so does the scope of traditional test-driven development, which gives you that nasty, nasty curve, which really impedes us from being competent engineering-like discipline, where we can't tell the business really how long things are going to take. Whereas if we do an immutable approach, we can guarantee a certain level of cadence to adding functionality, and we can get a proper velocity per event handler or per command handler, no matter how large the project grows. And we've been able to do this as a bet, bet the whole company on this concept, and actually go first foot forward with a fixed cost bid for a contract and say, yeah, we will only charge you this much, and we'll guarantee it to have no bugs. And it's been incredibly successful. I think this is what's going to change the industry. It's really going to change the way Agile's done. It's going to change the way software specifications are done. So it's quite exciting, because I think it answers a lot of corner cases that ended up being quite important in other successes like Agile, but they are proving to be the next big block for adoption. Specifically, I think one of the biggest ones is this inability to predict, simply because of that rework adding more and more things. You can show that quite directly with the example I gave you. If you're where the word event modeled is, if we show at this point in time in the number of features, if we're adding that, if this feature here is actually the lockout mechanism, we can stack on top of it, oh, I need to rework this previous thing, such as the registration, and we might have to do the forgot password, like look at it again. You can stack the things you have to readdress here, and that gives you why, what props up this red curve, right? So
Mhm.
that's kind of cool that you can show specifically, and it's why this article here is very important. It's to highlight that difference between how important state management is, and how we've been distracted with all the patterns books, UML, etc. We simply have very few patterns. All like in my I before we kind of went live on the air, I kind of said how each large system is a unique snowflake. However, the components are the same. We're solving the same small problems over and over again when you go from one insurance company to another hotel company to another point of sale system, etc. These are all just information systems, moving information from left to right, changing it a little bit and along the way. So while the systems themselves are quite different because of the different business requirements, we need to look a step lower underneath where we have a repetition of familiar parts. And that is the fact that each snowflake is still water, and that what we're exposing here is the molecular structure of water, and that we can always guarantee, no matter how unique your snowflake is. I don't like using the word how unique. No matter the fact that your snowflake is unique, the level of difference doesn't really matter, because when you look at it under an electron microscope, it is still water. It is still two molecules, right? It's still one molecule made of two hydrogens and oxygen or whatever, right? So we still
Interesting.
have that basic component, and the equivalent of that in event modeling is basically saying that we can describe any information system by having these four patterns that are described above at the top here, which are in the legend. You can look at them. Is that there's state change, state view, and an external state input and external state output. So it's essentially two core patterns of input and output, but it's easier to specify them in two different ways when it's a system to system communication versus end user or top level user into the system. So these do deconstruct to these two. And you'll see that these are quite familiar for you. Obviously, this is your given when then. And for your state representation, this is your given then, because on state representation, you have no action. You just have previous facts. And because you had these bookings, this is what your calendar has to look like, right? There is no command there. So these two core patterns really move through an elaborate sort of elaboration of these to be a four patterns that we talk about. And then we also want some simple rules to follow, and we want this thing to be explainable to people very, very quickly. So commands can only end up as events, and the only way you populate views is through events. So some other ways to people have used these things is to have commands go or events go straight to more events, etc. And that's a big missed opportunity, because if you actually have some sort of read model or representation of state at that point, it gives you a better talking point as to why the next thing is. And this is our processor. These processors are quite a key pattern to be able to show automation in the system, which is why we really automate most of our things out there, and how the computers do our work for us. So having this green part of this to-do list that a processor will execute for you is quite good for communicating how sagas or long-running workflows evolve over time, and how they're implemented and what's important to them. So that was the 101 of that. But I think the biggest introduction is just what it means for traditional systems. And this, to tie it back to the original statement of Fred Brooks about showing your tables. If you show the information changing in your tables, you can show direct coupling here within your tables with different workflows. You can directly see how many potential other workflows you have to refactor when you're adding new piece of functionality to an existing system, because you have these swim lanes of where the data is shared, right? Like the old adage, don't integrate by database, right? It's not really good. Here you can show exactly why that's not good. You can show exactly where that information from another workflow, let's, if I continue with this article, or actually when I continue with this article and show the further examples, we can see how if we do this ahead of time, we can identify those coupling points. And so in this example of registration, we can, when we get to this task from our Kanban board, we can automatically know that we need to put on a default um, number of failed attempts for login. Even though there's nothing in this workflow that talks about it, we can see by the shared swim lane data that this will deal with this other piece of functionality that's going to get addressed maybe a month from now. But we have this data completeness, knowing where data comes from, where it's being used. And that's where, even though we may have this nasty curve, at least we can quantify it, and we can estimate the area under that red curve to give a proper estimate. So event modeling aims to have to help both traditional systems, which is 95% of the world, and the people that are using ledger-based storage and doing event sourcing, right? They can hold the two solutions against one another and see, which approach they would want for each systems. And more to the point, you can mix them together, because this is just examples over a timeline. So you can have two systems shown here, one done on tables, which is traditional, and the other being done event sourced, where you actually do keep these events in a specific form, etc. So that's the idea. So this is a very important section of the book, and it really mirrors how the domain-driven design book by Eric Evans evolved. He stopped by our office last September and was nice enough to come by and say hello to everyone and all this. But we had a really good chat at the end, and it really took over 4 years to write domain-driven design, and it started exactly this kind of way of being one or two important papers, um, really talking about the two sections of the domain-driven design book eventually. So it was an initial paper, then a second paper for the strategic part. And then as people wanted more and more information from Eric, he said, well, I might as well just write a book. And that's where it started. But that whole process took 4 years. So what we're having in this case, what's happening in this case is a similar process. We've come to an understanding that there's a certain amount of advantages to dealing with information this way and being so explicit and focusing on that instead of the algorithms and other things that have been such a well, they've been over optimized. There's very little we can do to increase the output right now if we just do agile better, or if we just do Kanban better, or if we do TDD better. We need another leap of quantum leap of understanding. And the brave leap that one must have here is to not focus on the how, and to focus on the end goals. And the best end goal that we can have is to ensure that state changes like this over time. In other words, look at these tables or look at the events and the other approach. Is that what we get when we're done? Is that what the system's doing? I don't care how clean or messy your code is. There's many advantages in this approach here. We can have different stacks addressing each command handler. We've easily mixed Node and .NET development. Nginx routes different API points to different stacks. Underneath, it's the same event store that we're using. So there could be one piece here that's done in .NET, and the next one here is done in Node, and they work just fine. At the top, we have Nginx routing this particular functionality to .NET, and this one to Node. So to the user, it seems like they're using one system. Underneath, we can actually have 2 or 3 stacks, which addresses our big problems that we try to solve in alt.NET, of having polyglot programmers, programming teams, right? This is what we do. And because we have these as small bits of code that really are untouched because of open close principle, if that .NET developer quits and all we have is the Node developer, well, there's a bug here and they don't want to bother learning .NET. They can just rewrite this command handler in Node. And in fact, the test should be very easy to convert, because it's just data. It's just very property bag type of events that are givens, and the whens are commands, etc. So it's very easy to retrofit to a different language, or even abstract it away from the language, because now you can get into situations such as Cucumber and other frameworks that really don't care what the stack is underneath. And then now you really have a awesome polyglot story for everyone, right? So there's my brain dump. Now your turn.
Jeez. Wow. Talk about big batches. I thought the whole point was to work incrementally, and here it
I'm too excited about this, Roy. I'm sorry. You asked for it. I love this stuff, and I could talk about it all day.
that's on your local host, right? Or is that already on your website?
That's on my local host. The new articles on my local host. I will probably just work on it live. I actually do want it to be out there in time to really help people with the current remote situation. I
I
don't
think
want them to think that
put
they
it
have
out
to
there.
learn.
Put it
I'm
out there
sorry.
called beta so that people can read this, because I don't think I've ever heard anyone explain event modeling to this detail from basically almost scratch as you do. Obviously, you did it way too fast for me, so I'm going to ask you a bunch of questions. Okay,
Yeah, absolutely.
during this conversation, I'm probably going to ask you, and you're going to end up repeating most of it anyway. You just
That's okay.
words that I understand. Is that okay?
Yeah. So yeah, I mean, just to clarify, the main article about the event sourced way of doing event modeling is already there. The new article is the one that I have on the local host here.
So what's the
So
difference?
so this new one, the one that brings the remaining 95% of the population that's still using traditional tables for state, that's the new article that I want to put out this weekend, right at the latest, to really
That's
help
the
people. But
combination.
the theory and the implementation using regular ledger for events is already live. That's been live for a year.
So can you put the link to the public article somewhere in the chat so that we can have a
Absolutely. Yeah,
uh,
it's I've plastered it anywhere that I could find. So you can find it in my profile on Twitter. You can also find it. There's also a Slack channel for people discussing this, right? So
yeah.
we have
Is
a
it
global Slack channel as well. But let me see. I might have to stop sharing. You know what? You can do it on for me. All you have to do is Google event modeling, and it's the first hit. How about that?
you literally on you almost said let me Google this for you.
No, but that's with technical things. You don't know what you're going to get. Even for CQRS, you're getting really outdated information and not the right information. So I do hesitate to recommend. Let me Google that for you on certain topics that are important. I do want people to go to a specific resource. Luckily for event modeling, if you
Is
Google event modeling, you'll get that article.
I just put it.
Thanks to Hacker News.
Is this the one on the chat?
That you should see the same thing if you follow. Sorry, I can't see the chat because I'm sharing still, so I can
Ah.
stop sharing, I guess.
You should be able to see the under the share when you share screens. You also have like a small bar under somewhere, probably be
Mm,
behind it, and then you can have see the chat, whatever. Anyway,
no, I'll just see it now. Event modeling. Yeah, that's the one. Perfect. Yeah,
um,
and there is a resource section on there,
mhm.
which I mean, if you have a recording of this, I'll probably just put that in as well because I think our discussion is
Yeah,
going to be quite valuable to a lot of
it's
people.
all being
So
recorded and it's on YouTube Live, and it's gonna be.
yeah,
Now is the moment to share that stuff, and then people can go back to it. So, whatever you want to put,
absolutely.
you can put it in the chat and also in the YouTube chat, because this is
Yeah.
being done in Zoom and in YouTube at the same time.
Yeah, you can also, if you're wanting to ask questions, feel free to just share the screen from your end and scroll around to the sections that kind of talk about what your questions are.
By the
That
way,
might.
there's a Q&A panel for the people in the Zoom meeting. There's a Q&A,
Oh,
ability
good.
to ask questions, so we can also cover that. But meanwhile, I have a bunch of questions for you. Okay,
Absolutely, go for it.
you were talking, I was like writing down stuff so I don't forget.
Uh-huh.
Um, so some of these questions are really like like almost philosophical, and some of them are a bit more let's say down to earth. Um,
That's fine.
so what do you think is the relationship between functional design and event modeling? Do you see it as does one require the other, or does one benefit the other the most, or can you do is standard object oriented, is that okay, or do you think functional is much more suited to that?
Uh, I think it makes no difference, honestly. I think the mindset of having a customer driven approach shows you that given a history of things that have happened, when I attempt to do something, this happens. That is functional by definition, and it is real. I could do this in Bash scripts. I could do it in Scratch. I could do it in any kind of language. As long as I can audit the system that this happened, it does not require that. It certainly helps if people have come from a functional background, functional programming. It's really music to their ears because it's like, aha, finally we can have a way to talk about things this way,
Yeah.
and that's going to be wonderful for people that are huge functional programming proponents. Is that they will see what they would have done in F sharp being done in C sharp, and if they want to rewrite it, it's very easy for them to do so. Uh, all of the end goals are identical, no matter what your implementation language is.
Okay. That's
Does that
that's
answer your question?
yeah. It's so the answer is doesn't matter.
Hmm.
Um. So
I mean, obviously, there's an advantage for people that are working with functional languages is that they have a bit of an insight. They understand the benefits of immutability, right? So they have a bit of an advantage, but it doesn't mean that you have a requirement to use a functional language or to have a fundamental mathematical understanding of lambda calculus and other things. Absolutely not. It should translate to common sense for business folks.
okay. So next question. So how I think I kind of understood, but it still doesn't kind of fit in my head. So what would you do with a when you have a feature that says after 5 login attempts, lock the user out of the system? How would you do that in an event modeling process?
Oh, we do it by example, like I said earlier. So you would show exactly what, first of all, the easiest thing you can do to get going with event modeling is just to show what the screens should look like as you move through time. And say, okay, I'm going to log in. I'm going to put in the wrong password. I'm going to get this error. Sorry, failed. 4 more attempts allowed. Try again, right? Show another screen. It's all by example.
So you
It
start
literally is,
share the
yeah,
screen. There's a story. Maybe I can share it because I have the
yeah.
article.
Yeah. You can just go to the model that works near the top. If you share that, I can explain
Hold on.
um, by example how that specific feature would be implemented. And I can also go to Miro board and show you. Actually, I might share a screen with you.
Do it. Do it if you dare.
Right? I'll try. I'll try sharing this.
'Cause I'd really like to go through this kind of very, very small exercise in a
Yeah,
way.
let's do that.
And we can geek.
So, do you see my screen?
Yes.
I'm gonna go to
So what
this.
is Miro board that we're looking at?
So that's just one of the many online collaboration tools, which is what you want to do when you're
Like
working
Trello?
remotely at these days, right? And so you can basically use I
Is
don't
it like
know.
a Trello?
It's not Trello. It's more like a whiteboard, a digital whiteboard where you can draw anything, right? And they have a few templates for a few different things. And Yeah, I think, gosh, I kind of used one for Agile. Yeah, user story mapping at that. Sounds good. So I get rid of all of these things, and I just the nice thing about these kind of uh, tools is that with a touchscreen computer and a touchscreen whiteboard in a boardroom, the collaboration is so fast because you're really moving these much like they would be moved as real stickies, right? Oops. Let me just get rid of
Every
some of
time
this.
I've seen a company implement a touch screen big TV in a room, it
Uh-huh.
almost always ends up in huge failure of a flickering huge TV that costs a lot of money and nobody knows how to use. It's
Oh,
always
I
like
have the best. I have the best success story with one where we had to sequester a whole bunch of people to finish to specify a system with an event model because their previous attempts using all sorts of DDD and other modern methodologies failed. So we used that extensively. It helped quite a lot. So I have a good success story of that. But yes, traditionally, if you don't have a specific purpose for one of these fancy TVs, it definitely does get kind of fancy
but
toy
at
that
what
no kid plays with.
point 'cause let's say those TVs they cost like let's say $10,000 or something. So at what point is it really just about getting a whiteboard and moving things? Is it the only program is that you have to
Yeah,
do.
it has to be low. It has to be, so like I said, it has to be simple, and it has to be fewer rules. You can involve anyone. So really, if you're going to do this with analog equipment, it's one yellow sticky that you can get anywhere, a Sharpie and some paper to write, and paper
Is
to
that
mock up some
correct
screens.
using
That's it. Or a whiteboard. Like, you don't even need the paper. You can just use the whiteboard to draw, um, what's it called? Your mock-up screens, right? With
Is
data.
that your preference these days as well?
I'm sorry.
You still prefer to do analog versus digital?
If possible, because you get cues from people's faces in conversation, but it's not critical. And I think the idea that you need to be in person always doesn't scale. So one of the big differences with this is an event model ends up being a blueprint for your solution, just like you would for a house. And so you can't really always have everyone there whenever you have to address something on the blueprint. So you want to have an electric form that digitized form that you can share
Okay.
with people no matter where they are. And so this is one of the biggest opportunities for event modeling is with the current crisis. People can't be in offices together. You can do this with this kind of tool like I'm showing you right now. I'm just
Do
adding the wireframe thing here to make sure that we have it. Um, where did it get added? I think it's here. Yeah, wireframe. So yeah, we can just add the browser, as you can see. Then we can have your button. We can add some text. Register. Right. You can select this, copy it a bunch of times, and move it around. I'm using my fingers now to use the touch screen, so it zooms around quite nicely, and I can I can select the things that I want and move them around, and edit these to show failed login attempt. You see, quickly I can do this scenario, the failed logins, and while underneath I can very quickly get some events going underneath here and say that these are the events that are getting stored as I'm getting more failures, etc. Or I can represent it in tables like we have in this specific article here, where I can start to draw that. And in fact, these illustrations were done in this tool Miro, right? It's quite fast to do them, and you can do them collaboratively with others. So for a traditional system like this, I would still start with the screens. Like, what does the user see as they're failing to log in and they get that logout and lockout scenario? And then what happens when their 5-minute time limit is up? Can they actually log in again, and things like that? So it's very easy to describe things by example, but more importantly is to add the art of actually what is being stored in the system, either in an event sourced way or a traditional table sourced way, right? Table state, etc. And of course, you can, this is nothing. There's nothing saying that this has to be, tables. If you're using MongoDB or some other object database, that's fine too. Graph databases, they can all be expressed in their own swim lanes with demonstrations of how the information is stored over time, how the information changes over time. That's the biggest thing I keep coming back. This is by example. You show one thing only. There's no branching or anything like that. It's literally like reading a book. This is what's happening over time. And you can analyze it by paragraph, by chapter, by sentence, by letter, right? You can just move that timeline left and right to really investigate how the information is changing and discuss it, right? So
so.
go ahead. Yeah. This
Um,
is a Q&A, so I've been yakking again because I get distracted with my own voice. So
Back into the Miro stuff. So let's literally, because I want to make sure that I have the story in my head. Um, develop example. So if I say after 2 attempts, user is locked out, would you just start with the screen and then add an event next to it, or would you start with, let's say, the 3 screens, model all of the screens, and only then start modeling the events?
I especially if you're starting for the first time, I would always start with the screens because everyone gets it. Because
Mhm.
it's one of the trickiest things to start to get sidetracked with, well, what if two things can happen, and what if that things happen in parallel? We don't have any of that. We don't want any of that. We want to have a story and get the user experience right as soon as possible. So if I show, I can stagger these and put some, lockout error in between them, right? So let's just do this by example. So I'd move these over, move this one over, and insert some. I would insert some other things that would show, for example, just delete that guy. Let's see. Delete. I'd probably rename that try again or something, right? So that'd be try again. Sorry, I have to zoom in because no one can see what I'm doing. Right, so try again. This would be login. Let's just try that as, well, you get it, username or email. And then you would have your text box, right? Shout out to AOL, right? Password, etc. Oops. Let's try that from here. Sometimes the selections can be tricky. Let's see. I don't know. I guess he's still enter in that. Right.
Okay, so we
there's
have
one
like
screen, right?
okay, and then
of course we would have some message here.
goes like, okay, one
Wrong password. One attempt left. Right. Try again. And so let's just do two, since it's going to be trivial to do on the one. Right. And then we would take that, we duplicate it, move that over here. Obviously adjust that the user now has one attempt left, right?
okay, let's just do that. What happens now? Because eventually you'll want something that locks the user, and I'm looking for that place where we are closing the loop and there's something that reads. Uh, would you just read all of the failed attempt events for a user?
Yeah, that's the simplest thing, is that event sourcing isn't hard. You don't need to have some sort of a read model and a bus and all this other stuff. That's a big misconception. When I
Okay.
start using, writing these systems, I don't have any read models. I honestly just look at all of the events and do exactly what you said. It's an amazing application of Yagni, because the funny thing is that those queries that read the events this way, that code ends up just getting copy pasted into a read model. It's identical code, which is awesome. So there's an incredible amount of um, reliance on how the state transitions are done, and that becomes gold. If your business rules do not change, the same look at the events, how you're processing those things, for example, a lockout, that code will continue to live even when the system is fully fledged and running for 5 million users. There will be a lot of infrastructure in and around that as it's running in Azure or AWS,
Mhm.
but that core look at state still relies on these events, just as you had at the very beginning when you're just reading things off of a disk, or even in memory. If you're just doing this because you're in the development stage, you might not even want to touch the disk. You might just store these events in your session state or something, right? So it's really up to you, because that same code just moves to a different infrastructure,
So
and your tests stay the same, right? You have that nice abstraction. That means your tests throughout this whole thing, when you're doing TDD, are identical as you're going through these really low fidelity attempts with an in memory array of events. You could just have an array in memory, doesn't matter. The same logic moves across. And so one of the goals is to obviously have no reliance on a heavily opinionated framework that's going to affect your events. You want things to be very agnostic from the approach of how you store those. And this is one of the reasons that I'm hesitant to really recommend any CQRS or event sourcing frameworks to work with, because I think a lot of them still have high opinions of exactly what goes into the events. I think that should be very close to the business and not to a specific implementation. That's what's going to give your system longevity.
So I just want to make sure. So if I'm implementing a system where I either send an event or I read a bunch of events because I don't want to send an event. So when I press the try again button, what do we expect to happen? Are we just going to have code that first of all queries for some amount of events for that user and then just doesn't do anything? Or will we have an event that says another try and then there would be a query? I mean, what would you I guess what I'm asking is, would you have for each button try again, would you be running two actions, two behaviors, one that queries and then another that sends an event?
You could have one. I mean, I try to do the simplest thing and see if it fails. So if
How
there's
do
a
you know
possibility that someone has two tabs open or something,
you're setting an event? How do you know that it failed, that the login failed? How do you get that value back?
well, it would be a read model, right, from the next screen, which means that I mean, yeah, I would store an event obviously as I attempt to log in. I would have a failed login event, and the next screen would show perhaps, well, here you have one attempt left. So there's a business rule that would say, I have three attempts or five or whatever, and I count up the events of failed logins um, since the last successful one, or within a time window because they have timestamps, and I could show how many attempts are left there by just doing simple math.
And I
So that's usually how I would do it. And actually, that's a very good point that you raise. I think just the way that we have been accustomed to doing things really upfront, like having those default values here, etc. I think when people transition to event source systems, they tend to um, overload these blue command handlers. They want to do everything here so that they store the right thing. But it's actually the opposite approach. It's these green ones that are supposed to be nice and fat and full of logic. But these are supposed to be as thin as possible to just say, I have one objective, and that's to record a fact of what happened. I'm not here to inspect if it's perfect, to gather information from other lookups, etc. That is not my responsibility. My responsibility is to capture as fast as possible in the simplest way possible what has occurred and let the rest of the system continue. That is the
so,
number one job of these guys. So, if
so
that
just
makes
to make
sense.
sure that I understand then, because in a traditional system, usually there would be let's say an action to log in, and then there will be a reply from a service somewhere. It would bubble up as a response, as a JSON.
Oh, yeah.
Case, what you would do, just to make sure that I understand it, you would have, first of all, you would send an event, and then you would trigger a move to a next page. But what if you're in the same page? Would you just trigger another function that queries the current state, and then
Yeah.
show that's it?
Yeah. So you're touching on uh, two huge topics. The first one is that you mentioned you're going to go to another service to get the login, right? And that is true. That sometimes will end up being like an authentication service, etc. But what we're doing is we're trying to use this as an example for this is our domain. We're not going anywhere else. We're going to have this thing in our own tables right here. So, but to answer your question, if you did have it, that is the inter um, subsystem communication that you would have, right? If you wanted to call out an external system, and there's a pattern for that, and that's the to-do list and other things like that in event modeling. And one common pattern that comes out if you're going down the rabbit hole of doing event sourcing, you'll notice that any of these integrations really want this kind of write ahead log double entry bookkeeping where you say, I would like to I would like to initiate a call to do this, or I would like to reserve the right to do this and then do it. So there's always like these pairs of events for these integrations, and that makes it a lot easier to solve a lot of the other common questions that come about concurrency, latency, SLA, accountability of things like someone trying to fool the system for the wrong amount of logins, etc. So many things get solved by having this very common pattern of this write ahead log. And those are the topics that I get into in the book. They're kind of outside the scope of the introductory um, articles. They will end up getting written about in subsequent blog posts, but for a complete kind of set of information, the book will have that
Okay.
for these types of things. But the other thing you're talking about is single page apps versus traditional websites that move from page to page. How do you coordinate that? So there's a fair amount of logic that is really about just moving from page A to page B based on some outcome, and whether that is directly linked to some sort of a event handler or read model is really up to the implementation. What event modeling wants to strive to do is to make sure that what gets written on disk is accounted for properly. And with the implementation, which people really get hung up on, isn't supposed to be reflected in the event model. The event model is supposed to be the blueprint, right? It's about like having a blueprint for your house. You're not going to specify how the drywall is going to apply to stucco or things like that, right? They're going to have their own methodologies and you don't care. The blueprint says you want a wall there. And if the wall's there, you don't care how they did their job. You're just worried about the cost and that it happened and it works and it's the wall is there. So this is the event model is really, you always kind of go back and say, this is really the blueprint for what my information supposed to what my information system is supposed to look like if we did an audit of how the information changed, right? This is our gold standard, so that if I at the end of my project I'm running some examples through it, I can map everything that's going on underneath with the events that are getting stored and the screens that people are seeing. If I do a screencast, it maps one to what I had in the event model, and then everyone's happy, right? And it's this common kind of goal that we can get to, which really bridges the gap between business and the technical side, that everyone's working toward the same goal. And we don't get hung up on some of the details that I think in the industry we've been notorious for getting hung up on, and maybe in government organizations even more so, where we have 5 different architects arguing about really bike shedding if you look at it at the end. So this is really about being able to brush away those distractions of the industry, allow people to work collaboratively with a really clear goal of what success looks like. So it's the best thing is just to try it and get yourself into that mindset of holy smokes, I can really easily show what this timeline of using this application looks like. It's amazing. And I can see that if this actually happens over time, even if I just provide the screens with the right data, I can then have others help me put down some of the events, right? Maybe you need help with that, but it honestly shouldn't limit you to that. Business people should be able to say that when I register, I have a credit card or I don't
Yeah.
in that registration event. Those are important things to consider from a business perspective too.
Okay, so we shouldn't be caring about the implementation detail when we're doing these mappings, basically.
Yeah,
Cool.
yeah,
That's the point. That's an implementation detail. Okay. That's kind of like, yeah, it's really thinking in BDD. Is it, do I see the button or do I see the message, or and
yeah.
how you get
Let the
there,
programmers solve it.
which is a bit weird because on the one hand you're saying I don't care how we got there. On the other hand, you're definitely saying how we got there because you're saying we're using events and we're using event architecture. So on one hand we're saying you don't, but on the other there's just pure guidance that says no, you do write and you do read. So there's both focus on implementation and also non-focus, which could be a bit kind of, I guess
Well,
it's
let
a,
me explain. Let me explain, because I think it's slicing up state into manageable small little pieces to show how information changes over time, and that may give a very strong opinion on the implementation. So you're correct, yes, but we're certainly not doing it from a perspective of having algorithms being explained to business people, right? We
Yeah,
draw
not
the
yet.
line at that.
Sure, but the slicing of the architecture and the communication pattern, in a way, that's kind of what and I'm guessing that will later affect the implementation in a way. But I want to actually stop my question for a second because there's a question in the Q&A. Can you see it there?
Let me just check. You said that I should be able to see it somewhere with a little pop-up when I'm sharing the screen, but
The
I'm just
window.
going to stop. Oh, no, there it is. You're right. There is a Q&A. Ah, okay. I was looking at the wrong side of the screen. Silly me.
Okay, so
Okay, so how are you modeling back-end jobs? Payment authorization. Great question. Yeah, so that's quite common because there's a lot of line of business uh, applications out there that are maybe banking or something else or insurance, where there's a ton of back-end processes with very little user interaction. So it's like, what's the point of all these screens if I have 50 things going on in succession underneath? And the answer is quite important, actually, because even though we're dealing with things that may be just based on logic of the system and nothing to do with the UI, we have to interact with people that are visual. So first of all, the processors that may do something in behind there are explained in the article here. They're little gears. You can just pick them out of any kind of icon library. This Miro thing has a icon picker, which is quite nice, icon finder, which is quite nice. You can just type gears and it pops up and you can paste it in. And they all work off of these to-do lists, which is a great way to say that what's the next step going to work off of? What does that list contain? Such as send emails to this person or notification to this app or whatever it may be. But I think what I usually have for showing progress is even if they don't get implemented, I show monitoring screens like a dashboard. Let's say you have like a 6-step process of processing an insurance claim and it's all done in the back end. How do you use this to specify it? I would make, even though there is no requirement for it, I would make a screen that says progress of applications. They might very well want it in the end, but that gives some UI to this hidden process. It allows people that are visual to go to the event model and say, "Oh yeah, look, there's this giant gap between what I see here to what I see here. Why don't I add another swim lane for an admin? And in that swim lane, I'm going to add a dashboard because they might need to troubleshoot some things. So I might as well give them a dashboard of all the current processing jobs that are being done, which ones are in process in step 1 and step 2 or whatever. And I can show that progression, which is quite important. There is another caveat to that is when do you have really complex pieces of logic that, for example, in this nice happy path story, there is certainly a whole bunch of interesting things. Let's say the calendar has a whole bunch of non-trivial requirements. This is where you can take this particular view and make a whole bunch of these and basically give a legend. Say, put a big number 1 here and then number 1 down below and have a whole bunch of these things down here. And this plays on the specification by example by incrementally adding more and more events and showing how that status screen changes over time. I can show you that. It's kind of fun to do because essentially what happens is that if you have one type of report, which I'm just going to quickly duplicate this here. And let's say my report, I'm not going to type, it just takes too long, but I'm going to describe what goes in on all these things. So over here we have a report that by default shows, I'll type something, ready, and then purchased or booked room. This report shows, I don't know, activity 1 room. Then I can copy this. And here I can say canceled. I can say that this goes back to ready. And then I can do something else, such as embed. You can make a topical closed hotel cause COVID 19, right? So as I draw up what I would show in, some screen, I say this is complex. It's not enough just to show it here. Below, I can make this type of thing. Well, how does that screen change as different things happen? And I can really dive into that. This main workflow here gives everyone the idea of what the intent of the system is and does paint information completeness so that we know where each field comes from, where it goes to, and we don't have any missing holes. But here we get into the intricacies of just how some of that information changes. And it's really easy to build up. Okay, can you imagine that all of these just translate into a separate unit test where you just copy each unit test and just add one more event and then just adjust your assertion? It's incredibly formulaic, which is great. Software should be boring. It shouldn't be surprising all the time. We should be able to use this kind of way to elaborate, 20 different unit tests as they elaborate. Further, what we can do is if we have the same situation, but there's a second screen that shows some other kind of status based upon the same information, we can obviously duplicate that and have two specifications here where, oops, I don't want to move that guy. So now we can have two specifications, A, A, and oh boy, that's tiny. Okay, so let's try just bumping that up. They have A. And obviously, scenario B. All right, and then we can cross-reference that as being, duplicate this, duplicate that, and we can have a legend that shows those things happening here, right? If we're just pretending these are different screens. But we can show the evolution of these two important screens. Maybe there's a manager's report, the status report from the technical side that may show different things about what is going on currently. Oh, I missed some, oops. Okay, just got duplicated, I think. Anyway, does that make sense, Roy, in terms of what you would do for more interesting things? Back to the original question, I would say that anything that has a big gap and it's just a whole bunch of stuff underneath, you just put in some status screens for an admin, just so that the visual people that are more visual understand what the process is going through and show the important parts of the projections of those events that are storing the state of how those long-running workflows are progressing. So Christina, is that Polish? Looks Polish. I'm Polish too. So if that makes sense,
can you see it?
That would be really, yeah. Let me know if that makes sense for those things that are. So the background long-running processes. Sorry, go ahead.
So did you see in the chat?
Mm-hmm.
Okay, so because she's answering you.
Oh, okay. I'm just. I have question and answer. I see just one open, but let me just reopen the chat.
Yeah, there's like a regular chat.
Okay, hold on here.
Like,
I have open and answered. Okay, my chat is kind of screwed up. I kind of just see her original question only.
Actually, I created dashboards later on. It was our business monitoring, the final artifact of the project. And thanks. Hungarian. Yes, it is perfect.
Okay. Okay, I'm glad, and of course, I'm always on
Event
Twitter, and there's the event modeling Slack channel that is in the resources page of eventmodeling.org. So people are more than welcome to join the community, um, share examples and thoughts, and do all these fun things together.
Okay, does anybody else have any other questions that you can ask in the Q&A? If not, I have a bunch of them. I'll just give people. It really made sense to me when you were like putting things under like the different states, and then they led to the room being ready, etc.
Mm-hmm.
Um, okay.
Yeah, the buildup of a situation is really important, that you can chronologically see as you're increasing, adding more information on top of the already existing ledger. It's very powerful to show examples. We tackled incredibly complex situations in huge basket trades for a trading company, for a stock market, with wave acquisition over time, with incredibly complex scenarios. But looking at it from this end goal kind of approach, where we started with what's the default, give me an example of one event that can happen first, then build on that event, add one more, and we were able to address all of the really important scenarios and actually get going with a software with confidence that we're going to get a working system out on the other end.
So do you see a lot of do most trading systems have that type of architecture in a way, or do they use traditional stuff usually? Like that.
Uh, I think it's a mix of both. I think it really depends on your SLAs and the type of trading. I would think and would hope that most of them are event sourced, since you do need quite a lot of accounting like practices in those financial um, domains, because if something goes wrong, you need a reliable breadcrumbs behind you to show how you got there. Otherwise, you're in a big trouble to not be able to resolve why something went wrong. You don't
Yeah.
want to be swimming with code. You should be really looking at a paper trail of what happened along the way, and to understand how you can fix the situation.
Next one.
Hmm.
What maybe there isn't, but I've heard the terms event modeling, event sourcing, event storming. What's the relationship differences? Is it just all same words for different things? Different.
No, they're definitely different. The one thing that they have in common is the great insight that Greg Young had with event sourcing, is that the ledger mindset is an incredible boon to the information systems industry. Is that it is the first thing that really allowed us to step back and allow ledger to be used as a foremost way of storing things. Again, I go into the history of this at the top of the main article. That we certainly, from my perspective, we had forces of nature working against us as the transistor took over and integrated circuits became incredibly fast compared to what our storage technology at the time, how that was progressing. So event storming, event modeling, event sourcing. Let's go over each, the three main ones that you hear of. So event sourcing is the big one. It means that I refuse to use anything else except writing down what has happened on a ledger immutably to store what my state is, and everything else is derivative of that. So if I have a register user functionality, the most important thing I can do is just write down user registered, forget about any kind of table structures, anything like that. I just put that fact down, and that is immutable. It happened. Move on to the next part. Event
I
sourcing is essentially do. Sorry, go ahead.
sorry, I thought you were finished. The
No,
question was.
I'm gonna go over the three main ones, right? So there's my thumb. Three main ones. So the first big term is event sourcing, and that is the technical side of how you store state. It's very accounting like. It has less similarity to computer science. It has more similarity to accounting, and that's a really good thing, because we're really not solving a lot of math problems or redoing algorithms when we're doing our day jobs, at least for 99% of the population. We're doing the same patterns over and over again. So a better skill to have is to be accountable in your system for what has happened. And accounting is a much better skill to have as a computer programmer than an actual computer science degree these days, given the tooling out there and the maturity of the industry. Um, yeah. So that's that's the core thing. Event sourcing is taking that to heart and saying, I'm going to use an immutable ledger to continually to add new entries to it, and that is the only thing I'm going to rely as the source of truth for what the state of the system is. Event storming came out of Alberto's work with domain-driven design, agile, and event sourcing, and that is the idea that you can describe the problem space. Now they've extended it to look at solution space as well, but it's essentially a one-day exercise where you throw away the artifacts and it's there as a communication tool. So it's meant to be done in person one day to get communication done properly. Now, obviously, with the current situation in the world, that's not a good idea to force people to be face to face. So, event storming doesn't have very specific rules for implementation. It's about exploring. It's more about storming. The word storming is kind of like brainstorming. You just come up with ideas, explore your problem space. There really is no direct application of any specific implementation style. So there's been definitely a longer path to actually connecting it to some sort of way to start. Now, event modeling is the idea that an event sourced system is really something that can describe other systems as well. So it's kind of like E equals MC squared in physics. It's the one truth along the way that you have. Even like I showed here, even if you have traditional systems, you can still show them with this event sourcing kind of way, but
And the
you have but you just throw away the events, right? Like these yellow things don't get stored anywhere. So these orange things don't get stored anywhere. You're storing your stuff in tables, right? So the fact that someone typed in password or the password being secret 001, that's not stored anywhere, but it is capturing the event in some, logically that's what happened. That is the event. We just don't use it. So event modeling is really an idea that you can, by example, make a blueprint for any system, any information system. Whereas the other ones are event sourcing is the specific implementation of being able to look at events stored on ledger to do that. Event modeling is really about thinking about systems over time by example to show what your end goal is and what will make everyone happy, regardless of your implementation. You may not use you may, like I said here, throw away your events and use traditional tables. However, you can use the methodology explained here to come up with everything and describe traditional systems, right? And however, have your implementation done this way and still show that information there. So
is it fair to
event
say,
modeling is about making a blueprint, and none of the other ones are really about blueprints.
okay, is it fair to say that a system that is designed towards an event sourcing architecture, I guess, is
Mhm.
an event driven system, or maybe an event driven system is too generic? It already I think it's a bit of an overloaded term, but I've heard the term being used, but it doesn't necessarily mean that this is a system that uses event sourcing, right? I'm just making sure. Or do you use that term to mean that when you say an event driven system, or do you not use that term at all?
No, I mean, that's a really good point because when you look at non-databases like event technologies that aren't databases, Kafka is a huge one, right? It is not a database. It is a way of communicating and publishing events for other things to subscribe to them and interact using that mechanism. So that would qualify as event driven. However, that doesn't necessarily imply that the services that are listening to those things that are involved in that are themselves event sourced. i.e., they don't derive their state by looking at a ledger of events.
Mhm.
They're just listening for published messages. Hey, something just happened, so I'm going to light up this light. Okay, cool. Um,
Okay.
that's not really relying on. Usually, I think the finer point is that if you have a service has its own database of immutable ledger of events, that's event sourced. Everything else isn't. It can be event driven if they use events for communication, etc. You can have document, publishing, and then you have message based systems, not events, but they're publishing a new version of a document, and that's message based systems. So you can keep going more and more generic or general, I should say, more and more general explanation of these, high, architectural kind of terms. But I like to look at the core problem, which is maintaining maintaining this state, which I think is badly addressed in the industry. So focusing on just how we get from A to B in a system really relies on how we treat state along the way. And if we can be really crystal clear about that, I think all the other problems solve themselves by comparison. This is that cost curve, that rising cost curve, is really one of the key problems with the way we write software. Not having reliable estimates, really trying to do t-shirt sizing and a whole bunch of no estimates movements. That is not very engineering like. So this way of analyzing where, how information changes over time is really critical, because it removed all that cruft from UML, which was about the how, and concentrating just on the end goals of how you see information at a specific point in time is the middle ground. It gives you enough to understand the larger sort of goals of your implementation without having this onerous task of making a million different diagrams in UML.
Yeah. Would you do you, but then can it be overkill sometimes? Do you see places where it wouldn't make sense in terms, maybe it's just amount of complexity needed, or specific types of projects that doesn't make sense or doesn't fall into maybe real time? I'm not sure.
Which thing? Event sourcing or event modeling? Are you talking about the implementation or the specification?
The event sourcing.
Well, so I think in my experience over the last 12 years, event sourcing has certainly started from the infatuation of having this pub subsystem and this circular architecture, and there's been a very sort of addictive quality of the infrastructure that's to run. So if that's what you're talking about, yes, it's absolutely overkill for a lot of systems. However, if you look at event sourcing at its core component and just saying, hey, I'm just going to store this event in memory or write it as a JSON document as a file and continue to do that. And then I'm not going to bother with read models. I'm just going to inspect the events themselves to get going. It actually is the simpler one. I think traditional architectures really downplay some of the complexity of a single data model for the whole state instead of a ledger. It is what is now kind of situation for everything. And the devil in the details is in two places. It would be referential integrity, like this example that I'm giving, with having to later on put in some sort of a counter in either an associated table or a new column for logout tries or whatever. But this is just a very simplistic uh, example of interdata relationships that in a CRUD simple system end up actually exploding quite quickly. About, oh, this was a simple CRUD system, yet I'm getting this foreign key constraint problem, or I'm getting this null exception, or I'm getting all these data integrity things, because you're trying to balance a lot of plates in the air at the same time. You're spinning all these plates trying to make sure that all tables work with all tables at all times. And I think it's sold as panacea right now because everyone's used to that. It's much simpler to just say, this happened, I'm writing an event. If someone wants to interpret a whole bunch of events to show something, that's a responsibility that you're doing then, and you've passed it off in the Yagni style to be addressed then. So it actually is faster, very quickly. I would, for me, with my experience, it's the default approach. It's much faster than setting up any kind of database, any type of ORM. I just write down an event that had happened and take care of any subsequent problems or goals that I want to address through what's being displayed on a subsequent screen somewhere later. That's been way less onerous. Like for the company that I started does only this for 4 years, almost 5 years now in September, and it's incredible that we haven't had a bug that took more than 4 hours to ever fix. Like diagnose, flag, fix, done, deploy, 4 hours. I've never had that in my 30+ year history. Any other company, there's been issues with hunting down stuff, and because you never have that breadcrumb trail of like how you got there. By default, we have that with these systems, and it's just unbelievably powerful as to just how much of a headache it avoids with hunting down why are these tables in such a state? How did this change? And just not having answers and having to swim through code only to do that. Not only that, but changing code, having to go back to version control and see what was running at that time. It's incredibly tough compared to the event sourced way.
You wouldn't use it for something that's only in memory, for example, just keeping state at the same at the UI level. For example, imagine a simple counter application where you press increment. So you only use events when you need to literally say persist something. I'm guessing, right? Something that needs to be
Yeah, state change. Perfect. Absolutely. That's exactly what it is. State change is the most important thing that you can do with event sourcing. And it's gold. Like, yeah, example, like, you know, queried for current login attempts is not an event you want to do unless it's got business value for you to track that thing. But yeah, you literally want to keep that minimal.
Yeah.
Is this event being stored giving me a state transition that I need? Like, how little do I need to put onto this ledger to just show, to change the state of the system?
So you've been doing this in anger, I'm gonna say, for 4 years.
Oh yeah,
Like,
I love that. You and Oren try this in anger. A very angry.
what are some of the biggest gotchas or mistakes that you've made that you've learned from? That if people are just getting into this, what should they be aware of? That are probably going to fall into it. It's very easy. Or, like what are some of the important gotchas to stay away from?
So on event sourcing or event modeling? I mean,
Sourcing.
event modeling is really there shouldn't be anything. It should be a freeing experience.
Yeah. No, but event sourcing is the thing that I'm discussing.
Yeah, event sourcing is really about unlearning. And when I had an opportunity to work with Greg in 2008 and just hang out with him for a year, is the guy that really kind of taught me everything about it. It was a year of unlearning for me, and so I think that has always been the biggest challenge, is because academia, code camps, literature out there, tooling out there is all geared towards traditional table structure for state persistence, and so that implies quite a lot of tooling and quite a lot of approaches. So unlearning has always been the number one thing, as being able to clean your mind to a blank slate and be able to be in a position to learn um, something without being kind of swayed or distracted by your previous things. I mean, I loved a lot of the traditional stuff. I was a huge proponent of agile and TDD and the traditional things, and I was quite proud of knowing quite a lot of BDD frameworks, quite a lot of mock frameworks. I loved the fact that I could set up scenarios for dependencies and mocking, and that's one of the things that Greg knocked out of my head. It's like, you don't need any of this stuff. This is all cruft. You don't need mock frameworks. Or libraries. You can just have example events and have it so close to the real implementation that there's really no big danger of having your mocks falling out of sync with the implementation of the actual implementation of what you're mocking. So that was really one of those eye-opening things, but it's stayed as the number one thing. The other thing that people say is that, hey, if you're doing event sourcing, you're going to have like a million events. That's going to be non-performant. You have to like look at a million events to see what your state is. So there's the idea of closing of the books. A bank doesn't look at your transactions from all the way back to 1987 to give you your total, right? They close the books at, maybe for online banking, they close the books at the end of every month. Maybe for any foreign exchange things, they close the books at the end of the day. Maybe other things, they close the books. Taxation year, they close the books for those types of records and systems once a year. So closing of the books actually applies to information systems, not just financial information systems. And they may not be time-based. They may be other parameters that are based. But essentially what you're doing is you don't allow any specific substream to exist for too long. Because it performance, that's the dumb answer. But really it's about complexity and seeing that, this shopping cart has been open for 3 months. Like, what is the point of having that history there? That person obviously is either playing with the system or is not a typical thing. You shut that down, and whenever they go back to it, you have an initial event that may be sort of a snapshot, but you start a new stream for that. And the reason that's important is that it really allows you to do blue-green deploys. Because if you can imagine, if you had to always move every single event as part of the storage of a service, well, that would get slower and slower the more and more you had to move with it, with these really long event streams being dragged along. But closing of the books always means that you have the same kind of minimal footprint as you would with a traditional system in terms of what information needs to be moved to the new servers as you deploy the new version, right? And the other thing about event sourcing that's an incredible, there's about top 25 problems of software development that are addressed with event sourcing. One of them is data migrations. When you go from one version to another, event sourcing really guarantees that you're respecting any kind of change in your schema of events as they happen. You translate them correctly. And Greg has an excellent book on this about event versioning that everyone should read if they're into this. That just shows exactly how that is. So in these systems where before we had, data migrations were just killer. They're just super, super hard when you're going from one version to another. You have to make sure the schema matches with all of the old records plus the new version. Here, that problem doesn't exist. We map them as we go, and it becomes a non-issue. So a lot of the things that are plaguing the industry as being hard problems just disappear with event sourcing, which is why I always choose it as the default. You can always fold down to a traditional model after, but unboiling an egg going the other way is much harder. So moving from a traditional system to make it to an event sourced one is possible, but it's not easy. It's an entropy problem.
What is Greg's book?
Event versioning. It's on LeanPub.
Okay.
So look up Greg Young event versioning on LeanPub. You'll get it.
But do you still keep the old data around?
Yeah, I mean, it's the same thing as, it ends up being the same data management problem as traditional systems, really. You end up having, backups, cold storage, hot storage, SSD, in memory. You can keep going in this stair step of what's available, how fast and how hot, the same way you would with old backups of your database from last year or 2 years ago. You'd keep maybe on some sort of a magnetic media in your, in your storage. Until legally you can dispose of it or whatever, right?
Yeah. A couple more questions. You still have time, or are you done?
I do. I'm happy to spend as long as you can, because
someone is
I think it's really important. First of all, sorry, go ahead.
Someone is finally asking me.
No, it's important, I think, that people understand, especially the event modeling part, because it's such a nice way to communicate remotely while everyone tries to find better ways to work without having to go into the office. And one of the things about event modeling is that it erases so many meetings where you don't now need to be interacting with people on such a frequent basis. And that's going to help a lot with the current world situation. So I'm really happy that this, I have something to offer with event modeling to all the organizations out there in the world that need to be in quarantine, or just, good advice to stay home and not interact with everyone. So I'm really happy that there is something that applies to not only event source systems, but traditional systems as well.
Yeah, that's I think it's really kind of I'm gonna say it sounds like it's almost controversial, the amount of the amount of things that are different. For example, you mentioned, yeah, you don't need mock objects when you're dealing with event sourcing, which totally makes
Yeah.
sense. Mock objects make sense when you have a unit of work that communicates or that has an output into a third party system. But in
Mhm.
an event sourcing, you only have a single third party system, which is the system where you send the events to. That's all. So you have one component whose responsibility is to send events to somewhere. That will be the only thing, but it's basically a conduit.
Yeah,
The
it's
rest,
one more thing on that, Roy,
yeah,
is that one of the things about event source systems is that the the fact that you have event handlers and command handlers and that they are treated as pure functions. If you're into functional stuff, um, you will bubble up all your dependencies to be front loaded to give you the parallel in traditional procedural programming. Any kind of calls that you would make to external services, you'd say, well, make the calling code, get those, and put the results into the parameters, and then do your logic, right? So you kind of remove the need to have any kind of mocking within that, because you're basically providing the what the value return values would be. Now, the one exception is if you're working off of calculated values within that, and that's when you'd have to obviously separate things and get an orchestration going at the higher level.
okay, but still, eventually you have to send something somewhere. I'm saying
Mhm.
there's a single connection point in
Yeah, of
that
course.
system, which
But
is
you
just
abstract that. You abstract that. So in terms of having a cadence to giving you, well, all our command handlers take 2.5 days to implement on average. We can do really nice. Uh, we can do really nice forecasting of what the costs are going to be of a system. However, things like, well, how does this particular payment processor work, or how does this email service work? Those are unknowns, and you certainly want a separate statement of work or a separate project to take those into account, because they're not functional requirements. They're dependencies that you need to orchestrate and integrate with,
yeah,
but you still want your system to work. You can have those stubbed. You can have a separate page that shows, oh, this would have sent an
yeah.
email, and you show the whole thing working. But it certainly is a really good way to keep what your company has, your organization has as intellectual property, and what it is responsible for, as clean as possible. See the value you're giving and what those estimates are associated with that, and not get distracted by some of the integration points.
What happens when you need to change the schemas of the events? So you need more information that you did before. Some information turns out to be wrong in some way, or what happens then?
A lot of this is answered in Greg's book, which is good. But my example that I like to give is you have an online bookstore, and then suddenly you are going to have more mature books, and so you need to start to ask when users register for the date of birth. But your system was already running for a year with people registering without a date of birth on the registration part. So you've changed your system. Now your registration page has a field for when you were born, and your event is the new one, right? It's registered underscore v2. So do you now keep the logic for the old domain and the new domain? Of course not. You want to just keep the new domain. So there, in the event versioning book, it's a mapping, right? It's basically saying user registered. Whenever I get that, map it to user registered underscore v2, where it says date of birth. Put in a null or an NA, or maybe put in today's date, because that's guaranteed to be true. So and then allow the system to act as you want it to. So people that haven't um, provided their date of birth because they registered last year, they will not see those new books because it's age restricted. But it's a business question. We are now selling these types of books. So what do we do about the users that haven't provided criteria, whether we can show them or not? So you can then identify that we have a null in this new event, and the read models that that subscribe to it, they might project that information as well. And then when someone does, we can say we'll be proactive about this, and we can email all the people to a special page where they add their accept the new terms and specify their age, right? Or we do it at a point in time when they come back to the site and they log in again. The first page they see is please provide this to continue, or log back out.
What would be
It
the
depends on the business, but the key for you, I think, is what you're after, is that you don't keep the logic to process and take into account the old version of the event. You have a mapping so that you're only working with the new version of event, but it has a default value in that extra field.
like a nullable object in a way? What
Something
about
like that. That's implementation. It's up to you. Yeah.
you mentioned that you do get an event where you map, but a user has already been created. When would you create a new event for a user created with a null? Or are you saying there's a login event? Which event, what type of event did you mean where you
Oh, sorry,
map?
for the age example.
Like you said that you map a V2 to a V1 in
Yeah.
that. So do you go through the old events and then you add the values, or I'm
No.
just trying to make sure I understand.
So event sourcing is immutable ledger. So the
Right.
events actually stay on the ledger as the old ones. You start for the new people that are registering once you deployed the software. The new events are V2. However, when you're looking back, any logic that looks back at the history, for example, if you have your login event must look at whether you have this old registration event. The brand new functionality always expects the new version of the event, no matter what code you're running. There's
Okay.
one special piece of code that if it reads an old version, it maps it for you to a new version of the event so that you can keep your domain just dealing with what is now, what is the situation now, and you've accounted how you will interpret what happened last year in today's terms, which in this case may just be a null object or whatever you want. It's really independent of the implementation. It's more of a business decision, is like what do you consider a valid placeholder for this missing information. And then you might have additional information for the new for the old users, such as specified date of birth, or you might just simply override it by allowing the system to have a second registration event and ensure that the logic will only look at the most recent registration event for that same thing. So there's many ways to skin this cat,
Yeah.
but at least with the event model, you can show by example of how you're dealing with that situation, and business understands that, okay, this is how we're making sure that this new content is presented properly to the appropriate people and how we invite people that registered earlier, right? You can discuss that on the event model with them.
But the assumption then is that in terms of architecture or abstraction, where you read the events, because you can have multiple different places that read the same type of event, you're going to have to change all of them to map to the new event type. So you're going to have an abstraction for that specific event type of V1 to always make sure that whoever reads a V1, whether it be 5 different types of processors, they'll all get V2. So does
Yeah,
that happen in terms of your experience, that there are multiple reads from multiple places, and when you need to kind of patch things up, you then have to do a little bit of shotgun surgery in multiple places?
you do, but it's incredibly formulaic and reliable because, especially with statically typed languages, it's really easy to do that. But even with dynamically typed languages, it's such an explicit name of that event that you can quickly see where the use of the old event is. And you change it, and it always falls into that mapper to get the proper thing. So it's never been a big problem at all, and it's easily accounted for in the estimates for the new functionality. It's never
Okay.
really bloated out of scope or bloated a bunch of work that wasn't handleable.
A couple more
Simply
questions.
because we map those onto the event model, so we show which workflow steps have to change because of a new requirement, and that ends up being part of the budget for the change.
Okay. Um, I think so. You're saying because it's so simple, even the shotgun surgery is not a big deal. It's like, oh yeah, it's very easy to find. You pick up the things, and it's like a couple of lines of changes, and you already have the mapper somewhere, so it's just using it. Um, what
Yeah,
about
the shotgun thing is a misnomer in this case. It certainly doesn't feel like any kind of shotgun surgery. It feels very systematic and easy to manage.
okay? Um, what about I know that you said the implementation doesn't matter, but which databases are more conducive to saving events? Is it document databases? Is it? I know you said we can keep things in tables,
You
but
can, yeah.
which one is more user friendly in terms of event sourcing? Which
Well,
did
event sourcing, it requires two core things. You want to have guaranteed order and guaranteed persistence. So a few things kind of fail that approach. At least the old versions of Kafka published things before. It's like you had another subscriber that would have to store events for you. So if the power goes out, you're not sure who got what at what time, and whether you could actually find the original event in certain situations. So persist then publish is number one, and then guarantee retrieval in order is are two key things. So obviously, Greg has his project, Event Store DB, which is that's its entire goal is to support event source systems. However, you can, if you don't have your organization doesn't have the ability to absorb the cost of the additional operational complexity of adding another tool, you can use your traditional database or your file system as or key value stores. As long as you can index things and retrieve them in order, that should be fine. So, however, if you want to use the proper tooling, I'd highly recommend Event Store.
Event Store, the thing that Greg's building, is that already operational? Do you
Oh
can you
yeah, that's on version 6. A Swiss Air traffic control uses it. Jet.com uses it, which got bought by Walmart. So there's a ton of really large clients. That really large trading company uses that as its backing database for events. So yeah, there's a whole effort to have it as a first class citizen in Azure as a technology that will get the proper cloud support and all that. But it's on version 6 with commercial support. It's open source, so you can look at the code and do everything that you need.
Damn,
Yeah,
nice. I didn't know that.
yeah,
That's
yeah,
awesome for Greg. That's cool.
yeah,
So
yeah.
that's why
It's
he
a event. Yeah, it's eventstore.com. So
what?
eventstore.com. You can look at it there.
Cool. So it's open source, but it has like commercial licenses, basically.
Yeah, commercial support, kind of like the Red Hat model, open source. But if you want commercial support, you
Very
pay per
nice.
year or whatever. Yeah.
Does he support everyone himself, or does he have like a bunch of people?
No, no. There's a whole bunch of people now. It's a very mature project and product for commercialization behind it, and it's our
So that's
default for.
go-to tool these
I'm sorry.
days. So Event Store would be your like go-to tool when if you start a project that where event sourcing makes sense. That will be your first choice if possible.
Yeah, we use it. We use it for every project that we build, unless a client already has something else. But anything that we start, we deploy with Event Store backing the event
Really?
storage.
Even for small stuff,
Yeah.
or would you? Is it overkill for some things?
No, it's a very small process that runs. It's not a very heavy database. Like I said, it's got very small set of requirements to fulfill, and it's really optimized to be small, nimble, and fast to do those things. So it's incredibly easy to use on your local dev machine to experiment with. Just run a. It's a simple executable that runs on all platforms, and just has a data directory which it continually adds 256 or I forget if they upgraded it to 512 megabyte blocks, um, pre-allocated. So then it's just writing within those files as it adds more and more. TCP and HTTP protocols supported. So if you want text-based, you can see JSON right there, or it'll have a TCP encoded one for just pure TCP things. Yeah, but primary thing is that it gives you order and makes sure that things are stored on disk before they're published if you're subscribing to it.
So what would be the so is Kafka its biggest competitor at this point, or are there others in this
It's
category?
actually not a competitor. It's a misnomer because Kafka is not a database, right?
Messaging.
Kafka is a pub sub kind of messaging delivery system, a publish system. So it's being used in places to sort of be in place for what event sourcing is. So there's this kind of quasi thing, and they think there's a huge marketing effort on Confluent to really try to get it everywhere. But in reality, what the initial purpose of it was a publishing system for topics and things that are not as fine grained as individual entities streams, right? So yeah.
Other than Event Store, what are the some other players in this field that are specifically targeted for this type of work?
There's a whole bunch of people that have built a bunch of frameworks on top of RDBMS. We simply don't use them because we don't want to be tied to Postgres or any specific SQL Server or whatever technology for that storage. We want to be agnostic, and so we choose Event Store as being the thing that stores our events, and then you can choose whatever technology you want for doing the read models, tabular data, graph databases, whatever the fits the purpose for a specific view into the information. You can add those together. So um, I mean, there's a ton of them. There's a ton of open source ones. It would be disingenuous to put one ahead of the other. But in terms of something that does what Event Store does, there's only one, so it's worth mentioning.
Okay, and last question. I mean, we started covering it, but I was going to ask you, what is the rest of the event sourcing CQRS gang doing these days? Because I know there was a bunch of people from alt.net, etc. There was Greg Young, there's you,
Hmm.
Udi Dahan. I think there were a couple
Hmm.
of other people. Do you collaborate with any of them these days, or is it like each on their own in a way?
People have ebbed and flowed from one another. I've certainly become a lot closer to Greg. He's our chief scientist, and since we use Event Store, obviously, so he has worked with us closely. I teach with him many workshops around the world on event modeling, event sourcing, and CQRS. Um, I know Udi is still doing a lot of stuff. He's doing excellent work with particular software. He still teaches a lot about CQRS. He's an awesome guy. Um, and But I know he's got his framework for N service bus, which is doing well, and it's an excellent technology to use for PubSub. So that's someone that I talk to quite a bit in that space. There's certainly been a few others that have added themselves in recent times, but the original alt.net group that had CQRS and event sourcing was pretty much Greg, Udi, myself, and there's very few of the originals from alt.net days. Most of the others have come in since. Now that the scary part of introducing something new is over, and people are using it in production, especially with Greg's Event Store being used for mission critical things. Certainly, that's opened up the floodgates for other people to come in and contribute.
Are
So,
there
but yeah,
conferences on this stuff these days?
sorry.
Are there conferences on these ideas that are dedicated to event sourcing in some way? Are there any kind of communities?
There's definitely a big CQRS, DDD CQRS ES Slack that I'm part of, that I
Maybe.
partake in quite a bit. There's an event modeling one that I started that's quite large, growing larger anyway, because it's people like the ability to communicate event driven systems this way. So that's the recent one. Conferences, you always find a track of this kind of stuff, usually around distributed systems and microservices. That's always kind of talked about. Some people have added an extra day to make a small conference just about event sourcing, so it's getting traction.
Yep.
I think a lot of the 2 years ago, a lot of the hype around uh, blockchain and all that kind of stuff has shown people that you can store state uh, effectively with a write only ledger, and that's certainly opened a lot of people's eyes on how to treat information. So, uh, however, those are more kind of nerdy conferences about encryption and algorithms of that sort, and sparsely distributed ledgers and things like that, and computation. Not really about information system management and that kind of stuff. So there's definitely if you keep your ear to the ground for, look at the speaker bios and the titles of the talks. I see a lot of CKRS event sourcing talks at almost all kind of, at least the architecturally focused tracks in conferences. I definitely see quite a lot more of event sourcing and CKRS than I did 5, 6, 10 years ago, of course.
Cool. Okay. Any last words? I think we're kind of done. It's 1 a.m. here in Israel, by the way.
Oh, wow. Thank you for staying so long. That's amazing. I got to get rolling as well. I still have to really get my day going here. But last words are, yeah, just Google event modeling. I use 1L. It looks nicer with those two proper spellings, but Googling that either spelling will get you to the right place. Join the Slack community. Tell people about it because it's going to help you quite a bit in terms of being very effective at collaborating remotely so that people understand what you're building and how you're building it, and give you that real nice canvas that works well remotely, like I showed here with Miro. But there's Draw.io and all these other online tools to help you work together while everyone waits for this whole coronavirus thing to pass. You can still be very effective if you use event modeling. And then again, if you're using traditional stuff, it'll help you anyway. If you're in event sourcing, it'll help you there too. And if you want to tie the two worlds together or show the differences of the approaches, event modeling is the way to kind of show how you do event sourcing and how you do traditional, what the benefits, pros and cons are, how the information lives in this type of system versus that type of system, what the maintenance considerations are, and really that specification by example, this blueprint for what success looks like is key. So I'm very happy that people are noticing, and I'm very happy that you asked me to do this. I dropped everything I had planned to do this with you, and I'm very glad that I did. So really awesome to reconnect, and let's do
Really
more
great.
stuff together.
Yeah, I think I'm gonna do more of these because now that there's more free time for everybody to just sit at home and just do something online, I think
Yeah,
I'm gonna make it like a mission for me to just talk to a bunch of smart people that I know that know much more about me about specific subject. For the past 10 years, they've been like going at it, just like I was doing unit testing and the leadership stuff and the DevOps stuff, whatever. Um, so it's really cool to hang out with people that we started out and then we kind of branched out into these different, subsections. But I think we should all kind of start circling back and see, okay, where did we end up? Because you still have more thoughts about that agile, development can work differently in some ways. Maybe we can do like a continued session at some point to
of
talk specifically
course.
about that stuff. But your ideas about
I
maybe
would love to. I would love to. It certainly has a huge impact on agile.
yeah
We certainly have really important similar goals of having predictable software development, high quality, and all the things. There's just different avenues we've discovered in recent years that take some evolve some of those practices.
yeah. So it's not just engineering practices because I truly believe that engineering practices are they're the oil in the engine that drives the agility process. So you cannot be agile without enabling it at the physical level. And it sounds like this is it's kind of like you're saying, no, let's use a different type of gear in the
Yeah.
machine, and
Hmm.
then
Yeah.
it's like maybe when someone comes up with a smaller gear that you can turn with a larger gear, and then it turns like 50 times faster just because of the size differences. Like, oh,
Yeah.
simple concept, but makes a huge difference. Stuff like that.
Yeah.
Um,
Absolutely.
so maybe and another time when I'm a bit less tired and stuff like that, I would love to hear more about that because I think we should all be learning from each other in some way, especially since you cannot be like I've been doing unit testing in TD for the past almost 20, not 20, let's say 15 years, and it keeps changing. And it's
Yeah.
like I think the scariest part is to stay in the same place and then realize too late that no, there you missed a specific train there, and then maybe something that you think is true is not true anymore or doesn't make sense anymore. So it's
There's little danger of you getting something wrong, but I think there's definitely ways to add, more to your tool belt in terms of being able to help people,
Just tools.
right? Yeah.
Um, cool. That's it.
Okay, awesome, Roy. Thank you so much. Get some sleep. Hopefully everyone's well over there, and get
Yeah,
past this epidemic and
just
stay
canceled all the.
healthy.
They canceled all the schools in Israel
I
today.
saw that. I saw that. Yeah, as of Monday, right?
It's Friday because there's
Yeah.
school Friday here as well.
Yeah.
Yeah, we'll see what happens. We'll see what happens to work in next week.
All
Okay.
right.
Good night. Thanks everybody for watching and joining, and we'll put maybe some links under the YouTube stuff as well with links to your stuff. Thanks, Adam, and have fun over there. Be safe. Keep everyone safe. Don't kiss, don't touch, don't handshake, do whatever. And hopefully I'll talk to you soon.
All right, Roy. Thank you so much again. See you
Thank you.
soon. Bye.